Hello class, this video is to help you complete our last part of section 1.5, which is really just tying up loose ends about parent functions and all that kind of stuff for f of x and the absolute value of x, f of the absolute value of x. This should be able to help you do this assignment here, f of x and f of the absolute value of x. Also note, I put in Canvas at the top here a burning question. So if you're working on your homework and you feel like there's a question you can't quite figure out, post it in this discussion board, and then perhaps me or one of your classmates can go in and answer your question, either with a video or a picture or just explaining it. And there are all kinds of super cool instructions there to help you. So let's go back to this. First, one last thing I want to talk about is there's one new parent function, which is in that packet of parent functions that you worked on a few days back. So this one new parent function that I want to make sure we talk about is called the greatest integer function, which is kind of a brand new function for you. First, let's talk about what it looks like. You might want to put this on your in your packet with all the special parent functions. This one's on the last page. And it kind of looks like this. It looks like a bunch of steps. And the steps also go this way as well. So how does this function work? Basically, every time you plug in a value for the greatest integer function, which it looks kind of like this, there's a lot of different ways that people like kind of draw the brackets. A lot of times they're square brackets. Sometimes they're just kind of weird squarish brackets. They all kind of mean the same thing. So let's just say I was about doing a table of values here for the greatest integer function. So if I say x equals 2, y is going to equal 2. If x equals 2.1, y is going to equal 2. If x equals 2.5, y is going to equal 2. If x equals 2.99, y is also going to equal, you guessed it, 2. But the second I hit 3, then my graph is going to not be here. It's going to jump up to here. And that's going to be 3. It's also true on the negative sides, but it's kind of strange on the negative side. So perhaps I examine like -1. So if I get -1, I'm at -1. But if I do -1.1, -1.1 is like right here. So that's down there. So it's actually -2. -1.5 is also -2. -1.9999 is also -2. And that's how the greatest integer function works. It's a little tricky, especially when you're thinking about the negatives, because it almost feels like you're doing it backwards. Let's talk a little bit about how to stretch and shift a greatest integer function, because on your homework, you have a problem where you have to stretch and shift it. So if you start with your parent function, and again, you always want to examine kind of your parent points, but looking at this, we're going to zoom in on these 3. You want to kind of pay attention to how the open dots and how the closed dots behave. So I like to make a table here and examine my open and closed dots. I'll start at -1, -1. And then I have an open dot. I'll indicate that with a close. And then I have an open dot here at 0, -1. And then I switch to a closed dot again at 0, 0. And then I'm going to open dot at 1, 0, this point right here. And then I'm going to close dot at 1, 1. And then another open dot at 1, 2. I want to kind of examine how all of these points behave so I understand how the graph changes. So this 3, oops, and these are x values, and those are y values. So this 3 multiplies by all the y's. And remember my rule, anything with the x, I always do the reciprocal. So instead of multiplying each x by 1/2, I'm going to multiply it by 2. So now this -1 becomes -2. The 0 stay the same. This becomes a 2, and a 2, and a 2. My apologies, I wrote this point backwards. Should be the point 2, 1, and that's an open dot. So this 2 now becomes a 4. And then for all my y's, this is -3 and -3 because I'm multiplying by 3. 0 stay the same, and 3 and 3. So this basically tells me exactly how my brand new graph is going to look. Let's go ahead and we'll get a grid going here. So I usually like to start in the middle. 0, 0 stays the same. And then this open dot, which was 1, 0, now becomes the point 2, 0. And then I've got the point, this open dot, which was 1, 1, is now the point 2, 1, 2, and then 3, 1, 2, 3. And then this open dot became the point 4, 3. You can kind of tell just by this what the pattern is doing. Now the steps are 2 units long and 3 units apart. So you can continue the pattern this way. And it would continue in that direction and that direction. Now let's talk about domain and range for just a second. Domain of this function would be -infinity to infinity, because as I travel along the graph, every time I get to an open dot, that open dot is get picked up on a closed dot here and here. Range is a little tricky. The range I prefer, and there's a lot of different ways to write this. I prefer to write this in more of like set notation with these squiggly brackets. So we have, if you just have to really indicate the pattern. So I usually like to do like a dot, dot, dot. And then we have a y value here at -3. And then a y value at 0. Then a y value at 3. And dot, dot, dot. So it kind of tells you that you're going in the pattern of every third, or counting by threes or something like that. This is telling you that you do not have the numbers in between this point and this point. You're only having every multiple of third, not all of the decimals or like 1 or 2. So just keep this in mind. The last thing from section 1.5 is these absolute value functions. Now, this is more than just the normal V-shaped graph, although it kind of behaves in the same way a V-shaped graph does. So here, this is saying take the absolute value of all the y's, because you're taking the whole function. Here, you're just taking the absolute value of the x's. Let's talk about how this behaves in the graph. Let's examine the graph, just kind of a basic one. A lot of times when I have you do this on your own, I'll give you a picture and you need to manipulate the picture. But for our practices today, let's look at the graph y equals x squared minus, how about 9? And so real fast, if we make a sketch of this parent function, this is our f of x. This parabola is shifted down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a little excessive. Let's just do 1. Let's keep this graph small and simple. So we're here. So this is a parabola that shifted down 1. The x-intercepts are also right here. So here's our graph. Now if I want to do the absolute value, the big absolute value of this graph, I draw on my absolute bars here. This is basically saying that every single y value has to become positive. So anything on the bottom of this graph flips up to the top. So this vertex now comes right here. And this kind of curved pattern continues as it did on the bottom, but this is now more of a sharp point. So everything that was above the x-axis stays above the x-axis, and anything that is below moves up. Now let's look at the next one, which would be the absolute value of, or x of the absolute value of x. And so for that one, let's just look at a picture. So here's my function f of x. I'm going to say maybe we've got a couple intercepts here and here and here. And over here, the graph kind of goes like this. And then, or like that, let's say. When I do f of the absolute value of f of x, that's saying that every time I have an x, I'm taking the absolute value of it. So it doesn't do the same thing that this guy did. This one, every single x value that I use, whether it is positive or negative, is behaving the same way that a positive one would. So basically what happens is this side of the graph anything that happens over here on the negative end of the graph from here to here, this is gone. My graph is not going to behave that way anymore. Every negative x value is going to behave the exact same way that the positive corresponding x value would. So basically, this becomes like a mirror. The y-axis is your mirror, and this flips and reflects over it. So the same pattern repeats on both ends. And was originally part of your original function is now gone. To recap this property, you might want to just kind of add it into your notes. The absolute value of f of x flips any negative x value up above the, any negative y value up above the x-axis. And then f of just negative x makes a reflection of the positive side of Uh,